Okay, here's part 2 of adding radical expressions. Let's get that focused. Okay, so what if we had some weird ones? What if we had the square root of x squared? Well, the square root of x squared is x, right? Because x times x is x squared. So we can have variables in the radicand. Let's look at one. Let's look at this. Bring that over. Fix that 80. So we have an r squared outside, and we have an 80 here. So first thing we should look at is if we can make any perfect squares anywhere. So what do we have? Remember from the last video. Well, with 80, we can do 16 and 5, because 16 and 5 is 80, right? So we have an r squared, and then we can go the square root of 16 times the square root of 5. And the square root of 16 is 4, so the 4 is now free, so it's 4r squared square root of 5. Okay, and let's just do the rest slowly. Minus the square root of 45 r to the 4th, and plus this. Okay, and again, let's look for more perfect squares. So at 45, so we know 9 times 5 is 45, so 9 is a perfect square. So we can do, well, let's put a minus here, we can do the square root of 9, and r4 this is a perfect square too. Square root of 9, r4, they're both perfect squares, times the square root of 5. 9 times 5 is 45. R to the 4th power is a perfect square, because you get r2. So I'll write this over here. We're going to have, bring it all, 4 r squared square root of 5, minus, now the square root of 9 is 3, so that's free. And the square root of r4 is r squared. R squared times r squared is r to the 4th. They're all free. They break away from the radicand, the radical symbol. And then we have the square root of 5. Square root of 5 in there. Remember, they were all connected, so they're all connected still. Plus we have the square root of 125 r squared. Okay, I'll get another marker again, go back to red. Now the square root of 125 is 25 times 5. Don't forget that r squared is also a perfect square. So the square root of 125 here, we can do the square root of 125, excuse me, it was 25 r squared, they're perfect squares, times the square root of 5. And the square root of 25 is 5. The square root of r squared is r. So they're free of the radical. They break free. So again, let's write it over. 4 r squared square root of 5 minus 3 r squared square root of 5 plus, this is free now, it's 5. And what's the square root of r squared? R square root of 5. There we go so far. Remember, we can combine like terms with variables, and we can combine like radicals. So they all have a 5. So what do we do next? So 4r squared minus 3r squared is just r squared. Let's use the red again. So here we're left with r squared square root of 5. And then we have 5r square root of 5. So can we do anything more? Let's lift this all up here. So they do have the same radical, 5, but we can't combine r squared and 5r, so it's just, you can just say r squared plus 5r, and that would be the final answer. Can't combine them, remember, they're not like terms. If they both had a r without the exponents, you can combine them. All right, let's do one more. Okay, so what if we had something like this? Okay, so the 4y is free. And what's the square root of y squared? Y. So now the y is free. 4y times y, 4y squared. So that's done there. And then we have a 5, it's minus 5, square root of 144, y squared, plus y squared, square root of 12, y to the 4th. Okay, so square root of 144 we know, that's 12, and the square root of y squared is y. So breaks that down. So now we have 4y squared minus 60, because 12 times 5 is 60, don't forget the y, plus we have y squared, and the square root of 12 y to the 4th. Okay. So, 12. Let's get another marker. Looking for perfect squares with the 12, we know that the 12 we can do the square root of 4, because that's a perfect square. Y, right? Y to the 4th. Times the square root of 3. And we can't do anything with the square root of 3. Bring that up a little. So we would have 4y squared minus 60y plus y squared, and then this 2y to the squared, right? That's the square root of 4y to the 4th is 2y to the 4th. Well, 2y squared. So this wouldn't be y squared. It would actually be 2y to the 4th, right? And then we'll have the square root of 3. So let's write that over. Bring that up there. A little messy. Okay, so again, the final answer would have been 4y squared minus 60y plus, we had a y squared here, but remember the 2y to the 2nd was free, so it'll be 2y to the 4th, and then square root of 3. Now, see if you can combine like terms. That's it, right? Because y to the 2nd is different than y to the 4th, and y is different than all of them. So this would be your final answer. All right, great job.